Welcome everyone. In this video, I'll be teaching division of surds. On the board I have 4 questions to demonstrate that. Question 1 says, simplify 15 over root 3. Question 2, simplify square root of 9 over 7. Question 3, simplify 1 over 2 minus root 3. And finally, simplify 3 root 7 over 5 minus root 7. For you to simplify any of the following, you need to remove surd from the denominator. Removing surd from the denominator is what we'll call rationalization. Rationalization clears surd from the denominator. How do we do rationalization? To rationalize, you use the denominator to multiply both the numerator and the denominator. That is 15 over root 3 times root 3 over root 3. If you do that, 15 times root 3 will give you 15 root 3 over root 3 times root 3 will give you 9. But 9 is a perfect square, so it will give you 15 root 3 over 3. Simplifying further, 3 can divide 15 to give you 5. So our final answer is 5 root 3. To the second question, we have root 9 over 7. This can be written as root 9 over root 7. 9 is a perfect square, so it comes out as 3 over root 7. At this point, we will now rationalize the denominator. Root 7 over root 7. We use the denominator to multiply both numerator and denominator. That is what we call rationalization. This will give us 3 times root 7 will give us 3 root 7 over root 7 times root 7 will give you root 49. And 49 is a perfect square, so it will give you 3 root 7 over 7. That's our final answer, because you can't simplify it any further. Coming over to this side, we'll have 1 over 2 minus root 3. If you look at question 3 and 4, they are different from question 1 and 2, in the sense that we have compound denominator. We have compound denominator. Now, this compound denominator is what we'll call binomial surd. Binomial surd. And what do we mean by binomial surd? If you look at this denominator, you discover that 2 terms are there. We have 2 and minus 3, minus root 3. It's compound in nature. It's more than 1 denominator there. So we say it is a binomial denominator. These ones are monomial denominators. Single denominator. When it is 1, it's monomial. When it is more than 1, like 2, we call it binomial denominator. So 2 minus root 3 is a binomial surd. 5 minus root 7 is a binomial surd. Now, when you have this type of situation, how do you simplify it? you need to rationalize as well. This time, you will bring what we'll call conjugate of the binomial surd. What do you mean by conjugate? It looks like the binomial surd, but the difference is in the sign. Simplifying 1 over 2 minus root 3. We'll bring in the conjugate, which is 2 minus root 3 over 2 minus root 3. Sorry, 2 plus root 3 over 2 plus root 3. It has to be the same, except in the sign connecting them. This one is minus sign, while these ones have plus sign. But everything has to be the same. Going further, we'll have this time this will give you 2 plus root 3 over 2 times 2 will give you 4. 2 times plus root 3 will give you plus 2 root 3 minus root 3 times 2 will give you minus 2 root 3 minus root 3 times plus root 3 will give you minus root 9. Now, simplifying further, we will still have 2 plus root 3 over 4. This and this are the same and opposite. So they will cancel out themselves, and we will have root 9 gives 3. And finally, this will give us 2 plus root 3 over 1, which is the same thing as 2 plus root 3 as our final answer. Going to the last one, which is 3 root 7 all over 5 minus root 7. Simplifying it, we'll have 3 root 7 over 5 minus root 7. Bringing in the conjugate, using the conjugate to rationalize it, 5 plus root 7 over 5 plus root 7. They look alike, except almost the same, except in the signs connecting them. So this is minus sign, while the conjugates have plus sign. So multiplying out, we'll have root 3 root 7 times 5 will give you 15 root 7. 3 root 7 times 7 will give you 3 root 49. All over 5 times 5 will give you 25. 5 times root 7 will give you 5 root 7. Minus root 7 times 5 will give you minus 5 root 7. Minus root 7 times root 7 will give you minus root 49. Going further, for the numerator, we have 15 root 7 plus 49 is a perfect square, so it will give us 7. 3 times 7 all over 25. This and this are equal and opposite, so they will cancel out themselves. Y root 49 will give us 7. Going further, we'll have 15 root 7 plus 21 over 25 minus 7 will give us 18. At this point, we can reduce this fraction by using a common factor. 3 can divide all two. So 3 divide this will give us 5 with 7. 3 divide this will give us 7. 3 divide this will give us 6. And this is our final answer. We have seen that to divide, to simplify fractions involving surd as the denominator, we need to rationalize. If it's a monomial denominator, you use it to multiply both the numerator and the denominator, as we saw in question 1 and 2. But in question 3 and 4, we'll have binomial surds as the denominator for question 3 and 4. And for you to rationalize it, you need to bring in the conjugate. And what is a conjugate of a binomial surd? They have to look alike. They are the same in everything except in the signs connecting them. Use the conjugate to multiply both numerator and denominator and simplify the resulting fraction. We have come to the end of this video. If you find it difficult to multiply or to understand the multiplication that happened in the course of rationalizing the surd, look for the video on multiplication of surds. That will help you to know how to multiply surds. Thank you for watching, and bye for now.